So basically, this started with Hal and Brook Farms here. Got in contact with Jane, who then contacted me, to set up something where we can really look at some of the big questions that local farmers have in terms of how they're managing the land, how they're managing the grazing, and what impacts that might be having on the long-term sustainability of the grassland. And so specifically what the farmers are interested in is some data for their farms and in different fields, how they've been managed on those farms. And specifically they were interested in soil carbon and also soil biodiversity. So we managed to get some funding from AHDB for 50,000, but that doesn't actually go all that far in terms of this sort of science. So 15,000 of that was actually earmarked for biodiversity measurements, DNA soil profiling, and the rest is basically staff time for various things. And of course the project actually cost a lot more than what we got funded for. So we had a whole gang of volunteers in terms of master's students and GDA students working through the samples. Okay, so really important is that this is a farmer-led research initiative. So I did not go to the farmers and say, this is what I'm going to want to research, this is what I'm going to do. The farmers came to me and asked, can I help them answer some of these questions? And as you can see, we attempted to answer some of those questions, but it's a lot more complicated than what you can really achieve in a 3 or 4 month project. So the big sort of aim was to address local evidence. So there's a lot of evidence out there, but the evidence often is specific to certain areas, to certain conditions. So whether some of that evidence that's out there is actually usable at the local scale is always a big question. So say here we're looking at hill farming in a quite specific area. Are some of those general concepts actually the answers for that area? So we wanted to have a sort of pinpoint some of the real evidence for this setting. And of course, why are we wanting to do this is long-term viability and sustainability of the farms. Yeah, so and the big idea behind that, of course, is sustainable grassland, healthy soils, and so ultimately you need to put in less inputs and so on. So it's a big, ambitious title here. So the scientific aim from the project was to identify optimal grazing management that enhances soil health and carbon content. So the original idea was across the 11 farms are involved. Within each farm, there's various different management approaches to different fields and so on, depending on what is actually being done. So what livestock is being used, whether the livestock are being mixed, what grazing management approach is being used, whether there's other inputs and so on. And so the starting point was to try and identify whether any particular combination of those elements were more beneficial for soil health and carbon content. So it's probably useful just to go over very quickly the methods or the key methods that were used. So the first one, which I've already mentioned, is that this was farmer-led, but importantly, it's not just the farmers came to me and said, this is what we want, and then I went away and designed it, organized it. It was developed jointly with the group of 11 farmers. So how the sampling was conducted, also what was the focus of the sampling. Of course, all this has to be within the costing of the project. Yeah? But within the costing of the project, the end thing that was decided was actually done jointly between different farmers. So the two key things there was to maximize the number of fields that could be sampled. Make sure, of course, fields are sampled across all farms. So you could come up with a very specific scientific question whereby you might be able to answer that just by sampling on 2 or 3 farms, and other farms would not be relevant. Yeah? So sampling across all the farms, focusing on as many different field types as possible. So when I'm talking about field types, I'm talking about fields which are managed in a different way, whilst also trying to make sure that there's replication in there. So from a scientific perspective, for the statistics, we basically need replication. So you can take samples from 4 different fields, which have basically been treated in a similar way. So you can then do some robust statistics on it. If not, you have the issue where, okay, you've got a difference between that field, field A and field B, but that could just be pure chance, coincidence. It doesn't actually tell you anything apart from there's a difference. Okay, we also collected data on field management and history, and I have to admit here that we haven't had time to incorporate all of this information into the analysis. But as you'll see, I think a lot of the results that we're getting is linked to what's happening or what has happened in the sort of recent past. And when I mean recent past, I mean last 5-10 years. So a lot of the things that we're seeing... Yeah.
When you say history,
yeah.
how far do you go back in terms of that, in terms of this study?
So to be honest, actually as far back as possible. But in many cases, there's new entrants here and so on. So you can only go back as far back as that farm was taken over. But ideally, for the detail, need a detail for at least the last 5 years, preferably the last 10 years. But what happened 30 or 40 years ago is, of course, also relevant. So if you have a permanent pasture where you had no inputs for 40 years, then that's information that we need. Yeah. So basically here, it literally is as far back as information is available. Okay, so the soil samples were collected from 142 different fields across the 11 farms. So the farmers collected these samples themselves. They also volunteered to do the most complicated type of sampling you could wish for. So each field was sampled with 5 cores along the sort of W thing, the traditional, I think it's AHDB W. And those 5 cores were then mixed up together and subsample taken out. So the idea, of course, of taking multiple samples from each field is that you're covering that heterogeneity within the field. But I think for the purposes of this work, even because of the number of samples, the number of fields that we're looking at, duplicate samples would have probably been sufficient rather than 5 replicates per field. So anyway, so 142 fields were sampled, and for all of these samples we are looking at carbon content and nitrogen content of those samples for each of the fields sampled. In addition, for the 15,000 that we had for DNA profiling, we could profile 83 of those fields. And the DNA profiling is basically picking up all of the different bacteria and all the different fungi in the soil, although there's, well, for bacteria, there's no guarantee they're really picking up everything. And for fungi, they're definitely not picking up everything. Yeah? So for the fungi, this DNA profiling, which actually wasn't cheap, they were not picking up the mycorrhizal fungi, which of course is a bit of a nuisance, because that was one of the things that Hal originally came to me about, was the mycorrhizal fungi. But Annie is going to be, or is looking at mycorrhizal fungi as we speak. Well, as we speak is probably on. She's in the middle of doing it for her MSc dissertation. So I forget how many samples you have.
We'll end up with 132.
So there's going to be 132 samples where basically she will be analysing the roots within those samples and looking at the percentage of roots colonised by mycorrhizal fungi. So basically get a picture of the abundance of mycorrhizal fungi, hopefully in different systems. And hopefully this time we will pick out some clear differences between how the fields are managed. Now, of course, there's other things that will come into play here, including vegetation diversity. So that's also something that's going to be factored into that side of the analysis. So what I'd like to do here is just present some of the sort of big pictures, big results from the analysis. Of course, the farms are all anonymized. So this is looking at soil percent carbon, so the percentage of carbon in those soil samples. So you can see quite a variation between the farms, which is dependent upon what's going on the farms, of course. So it's important as well to note here that some farms are basically purely livestock, so basically permanent or semi-permanent grassland, whereas other farms do have arable in there as well. Yeah, so it's a bit of a broader mix as well what's going on.
Is that correctly for bulk solvents?
Yes, so well, this is the actual percentage of carbon per unit mass soil. So it's not like carbon stock per unit area. Yeah. And of course, and just to clarify as well, this is samples taken from the top 15 centimeters of soil. So it's not something you can necessarily use for estimating full carbon stocks, because you'd have to go deeper down profile, but it gives a good indication. So we did the same for nitrogen, and very similar sort of picture emerged as in differences within farms. Now importantly here we have the ratio of carbon to nitrogen across the farms, and this is pretty stable. Yeah, so just an interesting point that the ratio of carbon to nitrogen is stable across the farms. Basically that's saying that any farm that has a higher carbon content will tend to have a higher nitrogen content.
Is that just available nitrogen or is it total?
This is total nitrogen. So yeah, so that's another little issue in that, yeah. So loads of, sort of big differences between farms, and I'd like to drill down into 2 or 3 farm examples of some of the differences that can be seen. So this is soil percentage carbon content for farm A. So across the bottom here you have how those particular fields were treated. Well, as an error bar, it basically means that you have at least 3 samples, so it gives you a confidence around your result. Well, there's no error bar, it's because there's only 2 samples, because that's the only fields that were available for those particular types. So here, at first glance, it looks like those fields where you have sheep continuously grazed and sheep grazed along with orchard have the highest percentage carbon. And at the other end of the scale there, those fields which are mob grazed with cattle in wet conditions have the lowest amount of carbon. So interesting here, you can also make this comparison between the cattle mob grazed under the drier conditions versus under the wetter conditions. And it looks like there's more carbon under the drier conditions. So if we only had one farm, one set of results, we could probably explain what's going on here. What gets complicated is that these patterns are not replicated across the farms. So farm D, again this is soil carbon content. On the left here you've got silver pasture, which again is coming up high, so it's sort of what you would expect. But what's also important is actually how long were these trees sort of established and things like that. So some of this is of course historical. So if you just go in and change and plant some trees, then it's going to take a bit of time before you see results. You then have at the other end the sheep rotational grazed with chickens have got very low carbon content. Now at first glance that may be something to do with chickens. After some further investigations, it's actually due to past management of those sites. Yeah, and so the whole point of adding the chickens in was to try and remedy some of these issues around carbon content. So whatever results you're seeing, the issue is it's not necessarily directly linked to what you're doing at the moment now, but what has of course been happening in the past.
Phil?
Yeah.
Is it a wise move to base so much land use policy around soil carbon, and can it be measured and tracked accurately?
I think you know the answer to that.
Yeah, but I want to ask you so you can tell everyone else.
Yeah. I would say no.
Okay.
Yeah. So measuring carbon is not a straightforward thing. There's also all sorts of other issues, and there's one of the big pushes which you're all aware of course, is tree planting, which may have benefits for certain benefits, certainly in terms of biodiversity, depending on what trees you plant. May have benefits in terms of climate change adaptation, depending on where you're using it. Depending on where you plant, it may help with increasing carbon in those particular soils, but that really, I would say, applies to arable systems. Once you're moving over to permanent grasslands, I would say there's very, very limited evidence that if you turn over permanent grassland and put some trees in there, that at the end of the day, you're going to end up with more carbon than you started with. Yeah, so the average content, carbon content of permanent grasslands per unit area is higher than temperate forests. Coming on to the question of measurement, if you're talking about the sort of short time scale, so you measure 1 year, you go in and do your manipulations or change what you're doing, and you measure again, you're not going to find any difference, or not something that's statistically robust. The chances are you're going to have to wait at least 5, maybe 10 years before you can actually measure something straightforwardly in terms of carbon. And even then, you've got to think you're not just measuring, like we did here, a sample of the top 10, 15 centimeters. You have to get that measurement all the way down the whole soil profile. If you want to have a clear picture of what's going on in a particular area, you can use specific methods like 13C labeling. So this is labeling carbon that's going to be taken up by the plants with a carbon isotope, 13C, which means you can then work out how much of that new carbon has been sort of stored in the soil. So, and that's how scientists would be going about looking at carbon budgets. Yeah, you'd be using some sort of label. But of course, that comes at a cost. So it's not something that is doable on all fields or all farms or anything like that. So it can point you in the right direction on what sort of things you might be wanting to identify. So I think that question also will probably lead on to the carbon markets and things like that. So again, how that is formulated I don't think it can really be based on the amount of carbon that can be measured. It's going to be more formulated upon, if you do these things, the assumption is that you're going to be improving carbon, and so you'll get a payment for that supposed increase in carbon content. And there's all sorts of other issues, of course, with carbon markets, but it's not the topic today. Yeah, so another interesting one here is herbal lays. And of course, herbal lays is used, like we saw earlier on, to improve the condition of the soil. So the key benefits there, certainly if you've got legumes in your herbal lays as well, is that you're potentially increasing your nitrogen content of the soil, but more importantly, you're adding organic matter to the soil over that period of time you've got your organic lays there. So it's a means of enhancing soil organic matter in systems where you've depleted it. So most arable systems have very low organic matter in the soil. There's no ecosystem out there that has got lower organic matter than arable croplands, apart from deserts. Okay, and you have to remember all of this land at some point would have been a different natural ecosystem. So by doing the arable, gradually depleted carbon content in the soil. So that has got two things to it, of course. It also means that you've got that potential to increase that carbon content. Another example here from Farm H. So again, some large variations here in percentage carbon content. Anybody want to explain why the herbal lays are so low on this one? Yeah, I think these fields are maxed out, is my understanding. They were maxed out, so it's not because there's a herbal lay on it that it's low. The herbal lay is there to try and improve the conditions. So again, and when you're looking at this sort of data, really understanding what the history behind the data is important. So this is not trying to say that herbal lays are bad. This is just saying that the fields that are actually under herbal lay at the moment have got low carbon content because of what happened previously. Yeah, there's also another interesting little difference there as well, whether it's real or whether it's historical. Herbal lay NG, that means non-grazed, versus herbal lay that's grazed. So here it looks like the ones that are non-grazed are having sort of slightly higher carbon, but whether that is a result of what's going on at the moment or past management, of course, is more difficult to say. Any questions on those carbon contents on the different fields. Yeah, Annie.
I was going to talk to you about this anyway, but with the soil carbon content in grasslands, when you convert it to woodland, is that lost, or are you? Because obviously you've got.
Yeah, so when you're doing that conversion, you would be losing carbon.
Silver
Yeah.
moisture was greater for all of them, so is that just the fact that you're getting the best of
But
both worlds because you're not?
You could view it like that. So it all depends on the density of the trees as well. Yeah. So in effect, I would say the silver pasture is basically grassland with a few trees in it, rather than woodland with little patches of grass. Yeah.
So there will be a sweet point between how many trees you put in when you start actually losing that.
I would say so. Yeah. And I think that's something that's more research needs to be done on as well. But certainly, there's a fair bit of evidence that historically some of the places where trees were planted actually resulted in carbon loss.
That soil carbon loss,
Yes.
not whole carbon loss, because obviously there's all the biomass in the trees.
So when I was talking earlier on about the total carbon content per different ecosystem, say temperate grassland versus temperate forests, it's soil plus vegetation. So even though in the forest you have a relatively large proportion in the trees itself, they have far less in the soil. So when you add the two together, you've still got less than in a permanent grassland.
Did you find any trends then? You're saying each farm is different because of the history, but did
Yeah.
you find any trends over the 11 farms?
No,
Nothing at all?
not really at this stage to explain what's.
Setting the baseline, is it?
Yeah.
And then you look.
Well, we are sort of further doing a bit more analysis trying to factor in some more of these background issues. But for example, in some of the farms you will see, or you might conclude, there's greater carbon if you're grazing with cattle than with sheep. In other farms you'll see the opposite. So there's no clear pattern that emerged from the different management approaches. But I mean, that could be masked by the history of the sites, of the different fields.
Is there a direction you'd like to explore around the carbon in terms of management and carbon, or another hole you'd like to go down, as it were, focusing on the carbon, or do you think we should perhaps focus on the carbon?
Yeah, so
on the biology.
That's a good question. Yeah.
And maybe should we link it to production?
Well, yeah. So one important point to consider there as well is, if everything is focused on carbon, then you're going to end up losing biodiversity. So many of the sites which are high biodiversity are not necessarily the most productive. So there's that thing there as well that's really important to understand, that maximizing biodiversity will not necessarily maximize the carbon, and vice versa, of course. Like I say, Annie is going to be starting a PhD, and she's going to be focusing down on some interesting aspects that have come out of this, and specifically is focusing on mycorrhizals to the plan, right, for the PhD. But any other things which are really quite novel may also be picked up. I mean, there's always a question of funding. So if we have money, there's lots more things that we can do. This AHDB project gives us sort of big, broad picture across those 11 farms, across multiple different fields. The next step would be to actually, okay, right, let's identify more precisely some key elements that we want to focus on. So this may be either sheep versus cattle, or continuous versus rotational versus mob grazing. So something like that, but pin it down a bit more to get a clearer picture of what's going on. So I'm now moving on to just present a few slides on the biodiversity. So this is biodiversity of bacteria across all the farms. So a lot of different species were actually identified. So 1,420 were identified across the farms. And there's a whole group in there, of course, that we still don't really know what they do. Yeah, so including some really common ones, for example, these ones here. Verruca microbio, I think it's that one. So those ones there, they actually it's something that's discovered relatively recently. They're actually ubiquitous in nearly all soils, but we still don't know what they do. Yeah, now clearly if you have groups of organisms, groups of bacteria, which are there, they must be doing something. If not, they wouldn't be there, basically. But there's a whole range. Also, the majority of these species are not named. So most species of bacteria in the soil, they do not have a scientific name yet. They're not known. So even less so knowing what they're actually doing. So that was across all the farms, and this is basically showing you the number of bacterial species per farm. So here actually it's pretty tight, as in there's very little difference between the farms. The one which may be slightly lower is Farm G, but that turns out to be a permanent grassland. So again, you have that issue of the less meddling you do, the expectation is that you have greater biodiversity. But this is not what this is showing. Yeah? So it could be that in some of the other farms which have got a lot more perturbations, that you have things in there which you don't really want. It could be that because there's a lot of perturbation in the system, that you're allowing different things to come in who wouldn't normally be there. And another point about this is that it's picking up everything. So it's also picking up dormant. So most bacteria in the soil at any one time will be dormant, will not actually be doing anything. So this does not tell you anything about the activity of the soil biodiversity or soil bacteria. It just says what was found in that sample. So a similar thing was done for the fungi, and around 800 species of fungi were identified. So the one issue that I have with this is the mycorrhizal fungi would be in this area here. Really very, very few picked up. Many fields had no mycorrhizal fungi picked up at all, and clearly that's an error, that's a fault. Basically the primer that they used for extracting the DNA is good for fungi in general, but it's particularly bad for arbuscular mycorrhizal fungi. So basically the system, and this is a standard system of looking at soil fungi, does not actually pick up the thing that everyone is interested in, the mycorrhizal fungi. So a bit of a flaw in that. So there are primers available out there, but again, that's ups a cost. So we could have gone and done specifically mycorrhizal fungi, and then we would have just been looking at this bit here, and we wouldn't have got any of this other information. So there's a couple of master students looking at extracting some further details from this. So this data came with basically lists per field of all of the different species that were found, including the counts of those different species. So you can identify which bacteria or which fungi are dominant across all the fields, which ones are dominant in some fields and are totally absent in others. So those are the sort of interesting ones, the ones which are really dominant in some fields, absent in other fields. The other ones to look at is identifying which ones may be actually pathogens, sort of not non-beneficial fungi or bacteria. Again, this is a time-consuming task, so you're looking for. So I've sent the Excel file to Hal because he was interested. But it's something that will take hours of work sifting through the list. So one other thing that came out of this is paying this sort of money. So this was £200 or more per sample. Paying this sort of money to get out a list of taxa which are there doesn't really help you in making decisions or anything like that. What's really important is to identify key ones and focus down on them. So it sort of gives a snapshot, but I would say, okay, it's pretty enough, that list, but it's not particularly useful.
Excuse me.
Yeah.
Have you looked at all in terms of pesticide use?
So that's an absolutely good question, and we also got that data, as in we got which fields have had pesticides recently and so on, but we haven't had time to factor it in yet. But yeah, so absolutely. So, but again, you would expect that some of the, certainly if fungicides were used, they'd be knocking out some of the fungi. But again, some of the ones, because this is not picking up everything, so it's not picking up the mycorrhizas, it's sort of a little bit problematic. So the fungal richness, so this is the number of species per farm. So there's a lot more variability. A lot more variability than for the bacteria. So a lot more variability between the farms, but also within the farms. Yeah, so the higher error bar is basically telling you the variability within the farms. But again, interesting here, so the Farm G permanent grasslands is showing significantly less fungal diversity than other farms. So if we'd only seen this for either the fungi or the bacteria, we might put it down to just chance. Because we're seeing it for both the fungi and the bacteria, it looks like something is going on. So what's likely to be happening is that, okay, permanent grassland has a certain level of biodiversity. It's a good level of biodiversity that it has to keep that type of ecosystem functioning. Whereas some of these other ones, maybe there's a lot more perturbation in it. So other things have come in, making the total amount of biodiversity better, which is not necessarily a good thing.
Is it only one farm though that's standing out? Doesn't it?
Yeah, but there's a fair bit of replication in there.
On the management of that farm, you know, that could be managed totally different from another permanent grassland farm, which had